Can I have Rahul Kumar on stage? Rahul is a data engineer at AntStack. He's an AWS community builder and a 3 times AWS certified person. His interests include data engineering and serverless. Can we have a loud round of applause for Rahul on stage?
Hello. Hello. This works, right? Am I audible? Awesome. Hello, guys. I'm Rahul Kumar. I work as a data engineer at AntStack. Uh, okay. Uh, so I hope everyone is awake. There's been a lot of Gen AI going on since morning, and even after this session, there'll be a lot of Gen AI. Let's take a step back and look at something very mundane, something old, which is ETL. How can we make our ETLs more efficient by running them on AWS Serverless? So today we're going to be talking about the ETL challenges, what advantages serverless gives. We'll also talk about one of the projects we worked on where we did ETL and built end-to-end pipelines. We'll also look at what services AWS has to offer, and we'll also look at other challenges and why Glue is a serverless ETL solution. So first of all, how does a data use case begin? So the step one is getting requirements. If you're lucky, you'll get the exact requirements and you'll also know where to pick the data from. But in most 90% of the cases, you'll get requirements from somewhere higher up in the management team. They'll tell you, I want this. They will not give you any information where to pick this data from or how you're supposed to connect the data. And so this is the most crucial step where me personally I've spent more time in getting requirements than building the actual solution. Once somehow you figure it out and get requirements, the second step is you start building it. And building itself has 5 sub-steps which we'll discuss in more details. And once you build the pipeline, you have to also manage it. So you can't build a pipeline and just leave it as it is, right? It has to be maintainable. You should have monitoring built in where you can identify any kind of failures. There are times when you build something and probably a week later someone from management team will come down and say, this is not what I wanted. You picked the right data, but I wanted it from a different place. There is management. And whenever we build a data use case, there are usually 2 kinds, batch processing and real-time processing. So these 2 help us decide what services to go with. Let's look at few challenges we have in ETL. One of the challenges is ever-increasing data sources. So a couple of years back, all the sources were probably CSV files and SQL databases, but today, the data sources have skyrocketed. We have IoT devices. We have to build pipelines to support those old solutions people are still using, which export data in files. Another one is data formats. So even the data formats along with sources are continuously increasing. Files, we have files, CSVs, data formats like Avro, Parquet, Hoodie. So these data formats are also ever growing. The third challenge we have is managing infra. So if you have built any ETL pipelines ever, and you had to set up your Hadoop and your ETL tool, and manage your Linux machines, you know how hard it is, right? You set up a cluster, you have 3 machines running, and suddenly one of the machines fails, and then you have to figure out how to add more machines. Is there compute available in that region, and all sorts of things. Then we have data integrity, which is very important. So in every step, right, when you are cleaning your data or processing it, you have to take care of the data quality. If one of the if the data messes up in any one of the stages, then your rest of the stages become useless. Then we have managed data tools themselves. So other than infra, you also have to manage the tools. You have Hadoop, you have Flink, and a lot of other tools, right? You have to manage those tools, apply patches, keep updating them regularly. And the last one is changing data requirements, which is never going to go away. You get the requirements today, you build something, and 1 month down the line or 1 year down the line, some guy will come, some new management guy, and he'll be like, I want something else. I want this plus this or something like that. What are the challenges with traditional ETL? So one of the major challenges is ETL, maintaining clusters and your auto scaling. The second challenge is your idle time. So imagine you're doing batch processing, and your resources are doing nothing for 90% of the time, and you have to pay for those resources. The next challenge is high infra cost. I mean, if you work in data, you know every service or every resource we have in data, it's very expensive. So, you know, you try to save every minute wherever you can. You want to shut down your resources whenever you're not using. And the last one is managing infra and tools. I mean, this is kind of repeated, but yeah, you get the point. So the serverless advantage. What advantage do we get from serverless? One of the advantages we get is cost efficiency. So it is pay as you use model. You pay for only what you use. You don't have to worry about shutting it down. You don't have to, worry about scaling it, because it has scaling built in. Reduce management, so you don't have to update the underlying tools or do any of those things. So your management workload is reduced. Then you have faster deployments. Since your team is focusing on the business use case instead of infra and tools, you get faster deployments, and you can go to market faster. So warehouse capacity. So this is something we built for a client couple of months back. It was a logistics client. And disclaimer: this image is not from the actual dashboard. This is something I got from Google. So we were building something for warehouse management, where client wanted something they can use to track the warehouse utilization and different stats, right? To simplify this, let's just focus on warehouse utilization. So he wanted to track warehouse utilization, whether they are, using their warehouses efficiently. So this is where the problem starts, right? ETL itself has these 5 different steps. First one is ingestion, then you have storage and cataloging, processing, consumption and warehousing, security and monitoring. We'll go into details. So for each of these steps, AWS has a number of services. I don't have all the services on the screen, because if we go through each and every AWS service, it will take us probably 24 hours. Remember, we discussed real-time processing and batch processing. So there are like 4 factors which help you determine which service to choose. You have real-time processing, batch processing, and then you have cost and performance. So you can use these 4 criteria to determine which service suits you the best. So if you want something real-time to collect real-time data, you can use Kinesis and MSK. If you have things running on your on-prem and you want to sync that data with AWS, you can use data sync. Then you have data exchange, where it's like a marketplace for data, where you don't want to do anything. You just want somebody has already done the work for you. You just want to collect the data and work on top of that. Then you have AWS DMS, which is data migration service. If you have some SQL servers running on-prem and you want to migrate the data to AWS, you can use AWS DMS. The second step is storage and cataloging. So once we have the data, now we have to store it and catalog the data. The first service is Amazon S3. It is the most go-to service, highly reliable. If you have if you're following something custom, so let's say it's a very old organization and they have some big tools and whatever is in AWS is not making sense to them, they can run a EC2 and store their data on EBS. You have AWS DynamoDB to store your NoSQL data. Then we have lake formation. So lake formation is again helps you catalog the data. You have RDS. RDS is your SQL database service. So if you have SQL data, you can probably put it in RDS. And then we have AWS Glue. So Glue is your main cataloging service. It offers something called Glue Catalog, which is basically a Hive meta store, which can store metadata about your data. So if you have data lying on any of these places, right, DynamoDB S3, you can use Glue Catalog to catalog the data and access the data like tables. For processing, so once we have the data, now we are going to process it, right? So for processing, also we have a lot of services. So if you're a person who's already running some kind of processing on-prem using PySpark, Hadoop, and you don't want to learn too many new things. You just want to migrate to cloud. You can use AWS EMR. You can for stream processing, we have Amazon managed services for Apache Flink. If you are starting new and you're developing new pipelines or new use cases, you can go with AWS Glue. AWS Glue has a advantage. It integrates well with all the existing services, so it will reduce a lot of your manual effort. And if you're a kind of person who doesn't write code, but you know what to do with the data, you can go with AWS Glue Data Brew. It basically gives you an Excel-like UI and a lot of transformations and options and integrations, so you can transform your data without writing even one line of code. If you're a person who deals with machine learning and you've been already working with SageMaker, so there is SageMaker Data Wrangler, which can be used along with with Glue as compute. So and you can do all your data transformations. And let's say if you are a new age startup, right, and everything is already on serverless, and whatever data you have is already good, but you need minor transformation on your events and stuff like that, so you can directly go with AWS Lambda. So once we have processed the data, the next step is to consume it and warehouse the data. One of the services we have is Amazon Athena. So Amazon Athena, so during your processing and even after processing, at any step you can go to Athena and query your data and check if it is all right. Then you have Amazon SageMaker. So if you're building something for machine learning, right? So you process your data, put it in SageMaker, and build your machine learning models. You have Amazon Redshift, which is basically an industry leading warehouse solution. So if you're familiar with Redshift, so you can use Redshift. If you're building some real-time dashboards, so you can use Amazon OpenSearch. So if you're building some monitoring services for your clients. If you're building something BI dashboards for your sales guys, you can go with Amazon QuickSight, which is a BI service for data visualization. So after this, we have security and monitoring. So once we build all this, we have to also make sure only the right people access the data. So one of the services we have is CloudFormation. CloudFormation is basically centralized management area for your data. So you can give permission to only required people, and only those people will access the data. Then you have Amazon Data Zones. So if you have multiple departments and if you have multiple organizations, you can use Data Zone to give the correct permission. So each department or each part of the organization has only the specific accesses. Like marketing team will have access to marketing data. Finance team will have access to finance data. We have AWS clean rooms. So if there are multiple organizations who wants to collaborate but don't want to share their whole data, they only want to share the end product or some part of the data pipeline, we can use AWS clean rooms. We have Amazon Macy. So basically, if you have PII data in your data lake or warehouse, you can use Amazon Macy to discover and mask your PII data. So let's just circle back. So what we were trying to build, Amazon warehouse capacity dashboard. Sorry, not QS. My bad. BI dashboard for warehouse capacity, and so we just walked through so many services. For each step we have so many services, and I didn't even cover all of them. So now our job was to narrow it down to the required services, and these are the requirements we got from the client. So first thing, client was using legacy tools, which exported data only in format of CSVs. There was no incremental export, so we didn't even have an incremental export. Every time you wanted to export data, you get complete dump. And since client was just transitioning or just moving towards data-driven company, they were like, we don't want to pay much, and we want to go serverless as much as possible, so that we can keep our cost down until we can understand how much money we can make out of it. So then we build the solution. This is what we came up with. For ingestion, we had to build a custom solution because the data was residing on FTP files. So some of the data was in SharePoint and a lot of other places. First thing we did was we bought all the data to Amazon S3. Then we used Glue to catalog the data. For processing, we used AWS Glue and Lambda because there were places where the very minimal processing was required to capture the data. So wherever we could, we use AWS Lambda. And for consumption, we didn't go with Redshift or some high, very expensive warehouse. So we just stuck to our S3 and Amazon Athena. And for consumption, we built dashboards with Amazon QuickSight. For security and monitoring, we used AWS Glue, CloudWatch, and Lakeformation. So from the previous slide, you can see 3 steps out of these 5 steps use AWS Glue. So let's talk more about AWS Glue, why I'm calling it a serverless ETL solution. So AWS Glue has services for each step, and all of those services are managed services. So that is why I'm calling it a serverless ETL solution. Let's look at the services AWS Glue offers. So it has a cataloging service to catalog all our data. If you are a no-code, low-code guy where you don't want to write code, but you know what to do with the data, you can go with AWS Glue Studio. It gives you a UI where you can drag and drop components and transform your data. If you're a developer or already a data engineer, you have AWS Glue notebooks. You can bring up a Glue notebook within 5 minutes and you can start working on whatever you're working on. If you're a no-code guy or an Excel guy, you can go with AWS Data Brew. And there is also this thing called AWS Glue Data Quality. AWS Glue Data Quality helps you monitor your data as it goes through different levels. You can set rules that, if something like this occurs, or if so let's say we are looking at exam data, and we always get wrong data, right? So you can set a rule that nobody can score more than 100, which is normal, right? So as and when it sees a record which has marks more than 100, it will flag it and it will let you know. Then we have PII detection service, which will detect any PII data and inform you. Then to combine all of this, we have AWS Glue Workflow. Workflow helps you design your pipelines where you can have your pipelines do some task, and then once that pipeline finishes processing, you can Glue crawler to crawl and catalog your data. So this is summarization of what I just said. Glue offers data cataloging, data preparation, and data transformation capabilities. Its serverless architecture auto scales to handle workloads. Supports popular data sources like S3, RDS, Redshift, and more. So for your Glue catalog to catalog data, it doesn't have to be in S3. It could be residing in DynamoDB or your RDS or Redshift. ETL jobs can be scheduled and monitored and managed effortlessly. It integrates with AWS services for advanced analytics and reporting. AWS Glue simplifies data engineering, enabling faster insights and decision making. I think I got the last line from ChatGPT. It sounds very interesting. So let's have a quick demo. I built a data pipeline where, so we had a data, timestamp data, warehouse location, capacity, available capacity, and used capacity. If only data was this simple in real life. I uploaded that file to S3, and now I move to Glue Studio. Here, so we have a lot of sources available. Since our file is in S3, I chose S3. I put down the file location and the format of the file. Then I selected a IAM role which had permissions to access this bucket. It took me some time there. So as soon as I assign a role, it starts provisioning resources to query the data and give you real-time information. Then what I needed was, so there are other sources available other than S3. You can see the list, it's huge. Then I wanted to make sure I get the right schema. So I added a change schema step. Since this was taking time, it was still provisioning and loading the file data. I went to the next step, which is basically transform the data and store it in S3. These are all the transformations available. I'm not sure if you guys can see what are the actual names. These are the targets available. We can put the data in any of those targets. So we're going to put the data in Amazon S3. We're going to store it in Parquet format. If you're from data engineering background, you must be familiar with Parquet format. Then we also said, along with converting it to Parquet, also create a table in AWS Glue catalog so that we can start using the data immediately. And so this is our schema. And if you guys see, the total capacity and all of those were considered as string. I changed the data type to a big int, saved the job, and ran it. Should be running it. So now the job is running. I didn't write any of this code. All of this was generated by AWS. We can look at the script. We can also edit that code if you want to do something custom. We have job details where we can look at things like cluster size. So worker nodes, minimum is 2, maximum, I'm not sure what's the maximum. Our job is running. It takes around 20 seconds to bring up the resources and start doing its job. We have data quality. We can schedule jobs for batch processing. And I think recently we got support for version control. I think a year and a half or 2 years back we didn't have this. So I sped up this part of the video. So I mean we can see the results. It succeeded. So if we go back to our S3 now, we should have a folder called process data where the data is in Parquet format. Now what I'm doing is I'm going to QuickSight dashboard, importing the data from S3 using Athena as source. Select the database default. Almost done. So that's it, right? I basically imported the data into QuickSight, and now we'll quickly generate a warehouse utilization graph. We want a warehouse based on timestamp, like show the data based on timestamp, show use capacity, and show based on the locations we have available. If you see the warehouse, we have 2 warehouses where utilization is kind of moving towards equilibrium. Also, this is a second demo where we're creating a notebook. For those of you with the data engineering background, you know you have to first create a cluster, maybe create a dev endpoint, and then connect your notebook to that endpoint, right? Here, we are doing this in AWS Glue. All I have to do is click on create new notebook. This takes a couple of seconds. I've sped up the video. I think it took me like 5 minutes to get the notebook. I will let it take its time. So the point here is, I didn't have to worry about creating any clusters. I didn't have to worry about setting up any tools. All I had to do was go and click few buttons and get our resources up. We got a notebook and I can immediately start using it. I built a whole pipeline for a very simple use case within like 5-10 minutes. It took me more time to edit that video than creating the actual resource. So, I mean, with this, I conclude that serverless is way forward, and serverless will bring more efficiency to all your ETL workloads. With serverless, you can focus on the actual business logic than creating resources and monitoring those resources. I think that's it from me. Did I finish early? Thank you.
Thank you so much, Rahul.